Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone, and welcome to Mammoth Interactive's Complete Machine Learning Course 2.0. In this course, we are going to build unsupervised neural networks together. This course is beginner friendly, and we are going to go over everything that we'll learn in this lecture. If you don't have any experience with machine learning, that's fine. We are going to take you from beginner to getting powerful skills in a very high demand field known as machine learning. Let's go ahead and jump into an overview of all the projects you're going to build in this course. It's a very projects-based course to give you a strong portfolio. Let's go ahead and jump into the topics. First off, we're going to learn what is unsupervised learning in the first place. We're going to build our first project together of an autoencoder. You'll learn exactly what is an autoencoder neural network, and you'll build one together with us. First, we'll prepare data for the autoencoder, and then build the weights and biases for the functions we'll need. And then we'll build an encoder and a decoder together. This is a very exciting project. It utilizes the powers of computer vision. So it's a great one to start off with for our unsupervised neural networks course. Following that, we're going to continue building an autoencoder by optimizing it and then training it on a data set. We're going to use hand-drawn digits, as you can see visualized on the screen. And finally, we're going to visualize the reconstructed images. An autoencoder actually learns how to draw, and so we can visualize what our machine learning model drew. It's very exciting stuff. Next up, we're going to dive into project number 2, a deep convolutional generative adversarial network. This is another type of neural network that utilizes deep learning and unsupervised learning. This is also teaching algorithms how to draw. That's the project we're going to be focusing on. But of course, all these neural networks and unsupervised learning, they have many more applications as well, many more projects you could build, but these are the fun projects we are going to use. We're going to learn what is a generative adversarial network first off. You'll get just enough theory to take you through all the projects of this course. After learning what is a GAN, you're going to prepare data for the neural network. After that, we're going to build a generator to generate images. This consists of several layers that we'll have to put together for our neural network. Each layer is a mathematical function, and it has a separate task. We'll go over what all the layers mean, why we're putting them together, and how to actually code it out. We're going to build a batch normalization layer and apply a leaky ReLU activation function. Don't worry if none of these terms make sense to you. We're going to go over all of the terms you need to know. There are many terms that will probably be brand new to you, as is the case in machine learning, but we're going to go over all the terms and functions you need to know in order to get hands-on and build working projects together. We're going to then add a transposed convolution layer to our neural network and apply a hyperbolic tangent activation function. This is the bird's eye view of the makeup of the neural network we'll build. Following that, we're going to build a discriminator. A discriminator works hand in hand with a generator for unsupervised learning. The generator is the artist creating images, and the discriminator is the critic that can determine, is an image real, meaning it was created before the algorithm, or is it fake? Was it created programmatically by an algorithm? To build a discriminator, we're going to learn how to calculate loss, how to optimize the network, how to train the network, and visualize test results. So first we'll build the discriminator, and then we'll train it with the generator. Those two are a pair, and we'll go over that project when we get to it. And that is the bird's eye view of all the projects and topics we're going to cover in this very exciting machine learning course. Together, we're going to build unsupervised neural networks, which are really going to give you a powerful skill set, a powerful tool at your fingertips. Coming up, we're going to see the applications of unsupervised learning. Unsupervised learning has uses across all industries, making it a very in-demand skill. Let's jump into seeing just how important unsupervised learning is, the power it can give you, and we're going to break it down on a technical level. I'll see you in that next lecture. Hello everyone, and welcome back to Mammoth Interactive's Complete Machine Learning Course 2.0. In this lecture, we are going to learn what is unsupervised learning. Throughout this course, we're going to build unsupervised neural networks, but before we jump into hands-on projects, we have to actually know what is unsupervised learning in the first place. Let's get started. Let's first talk about applications of unsupervised learning. That way you can see just how valuable it really is. One application that this type of machine learning is used for is to provide recommendations for purchases or videos to watch by companies like Amazon and Netflix. Another application is to group customers based on attributes, such as all of these customers are likely to purchase this product and all of these customers are likely to not purchase that product. Another application of unsupervised machine learning is in biological and scientific research, like for grouping species and grouping people by genetics, and not only people but animals, plants, by their genetic makeup. Another application of this type of machine learning is to distinguish between different kinds of tissues. Machine learning is commonly used across all types of industries, including the medical industry and, of course, the business industry. Some more applications are you can create customer personas for businesses. You can make a customer profile, kind of like Facebook makes a profile about you in order to then send you targeted ads. Another application of unsupervised machine learning is, will this customer buy item B if they bought item A? It helps with marketing because you can send your customers down a certain marketing channel based on their customer persona. But applications of unsupervised machine learning aren't just in business making money. They do have broader applications as well, like with translation and, of course, in the medical field. Another application is to detect bot activity. You can use unsupervised learning to detect abnormal activity, such as the use of a bot on your website. Even more applications. Last page, I promise, then we'll get into what it actually is. But I really want you to understand how important unsupervised learning is and how useful it can actually be. So let's talk about even more applications. Another application is to recognize handwriting. You can recognize what words are, kind of like those apps where you can hold it up to a piece of text and it can translate it instantly. So computer vision. This is actually the projects we're going to be focusing on, are computer vision projects. They're very fun, like you can recognize handwriting. Another application of unsupervised learning is to recognize speech, and similarly to create speech. That's right, you can create books, you can write sentences, all using a program. So that means that your neural network can generate words. It can even generate a Shakespeare play based on the Shakespeare plays it has read. It's a pretty general description, but it can do that. As well, unsupervised machine learning is commonly used for tagging parts of speech. This means you can take a sentence and find the noun, find the predicate, the subject, all those good things from English class. You can do that with unsupervised learning. And why is that useful? Well, because this helps you train a model to read and actually understand context. This is very important for translation, because reading a sentence isn't simply about understanding each word individually. You have to understand the context around the word, because a certain word like tag, that could mean anything. That could mean to play tag, or to tag a part of speech, or it could mean a tag on an item at the store. So you have to understand the concept, the context around the word to actually understand the word itself. That's why tagging parts of speech is important. And finally, another application of unsupervised learning, which I've already mentioned, is to translate text. Google Translate very commonly uses unsupervised learning. Really, it's the only way it can translate text. And you might think it's not that accurate now, but that's because unsupervised learning still has a way to go. It's a relatively new field. There's a lot to discover for sure with unsupervised learning and machine learning, artificial intelligence in general. There's a lot that you can be on the frontier of. So now that we know how important unsupervised learning is and the power you have in your hands potentially after this course, let's actually talk about what it is. Let's get into the nitty-gritty of it now. All right, let's talk about machine learning as the three branches it has. The three main branches. There's supervised learning, which we've taught before, and then there's unsupervised learning we're teaching now in this course, and then there's also reinforcement learning. There are other types of learning as well, but these are the three main branches of machine learning if you think of it as a tree. The three main parts is supervised learning, unsupervised learning, and reinforcement learning. In this course, we are focusing on unsupervised learning. So what is supervised learning? Let's start with that, because you may be familiar with supervised learning, and it's really good to compare and contrast the two, because if you know what supervised learning is, you can very easily contrast it with unsupervised learning. Supervised learning is a type of machine learning task, and it learns a function that will map an input to an output. That means it learns how to get from X to Y, how to go from an image to saying a number 9 is in that image. And how does supervised learning do this? It uses sample input-output pairs. That means it will take an image that has a label, this image has the number 9 in it, and it learns from those labeled images. For example, if you're working with images. That's supervised learning. It's called supervised because it works on labeled data. It has images with labels. Now, the direct contrast to supervised learning is unsupervised learning. It's another type of machine learning task, but this time it does not use labels. So where supervised learning had labeled images, unsupervised learning could get the same images, but they would be unlabeled. And that's just because it's a different way of training a model to develop an algorithm. It's a different way to train intelligence. This time, we're looking for new patterns in data with no pre-existing labels. This is commonly done. For example, they sent an unsupervised model on YouTube videos and it came back recognizing cats. It didn't know the label was a cat, but it knew that there was some pattern about a cat shape on YouTube videos, and that's just because there's so many cat videos on YouTube. That should give you a good idea of what unsupervised learning is. You kind of send it out into the world, you send your model into the data without any supervision, meaning you don't help it with labels for the training part. It trains on its own without you giving it any labels for the data. There's very minimal human supervision. Whereas supervised learning gets the X and the Y, it gets the image and the label of what is in that image. Like this image showing a cat has the label cat. An unsupervised model will only get the image, it won't get the label. It's just another way of training, and it's highly effective. Unsupervised learning contains two main components to it, two main parts. First is the principal component analysis, and then there is cluster analysis. Let's break down these two to help you understand unsupervised learning at a more technical level. Let's start with principal component analysis. This is part of unsupervised learning. We're going to be directly applying these concepts into code shortly, but let's do an overview of it on a visualization point of view. Here we have principal component analysis visualized. We have our data points being plotted based on their features, feature 1 and feature 2. And we are going to extract the principal components from the data. We're going to extract principal component 1 and principal component 2. We do this because data is very noisy. You might get an image of a number 9, but there's a bunch of irrelevant features in the image that aren't actually important to labeling the image as a number 9. That's why principal component analysis is the first step of unsupervised learning. It's pulling out the most important features from your data, like your image. Let's break down principal component analysis. Data is noisy, as I mentioned, so we have to perform dimensionality reduction. That means we reduce the dimensions of your data, such as you take an image and you reduce it from 3 dimensions or 2 dimensions and perhaps to 1 dimension. The idea is you're just getting the most important features, the principal components that make that image have a certain label. You're going to get each data point's first few important components, because otherwise you would have so much data it would be too complicated to work with and too slow to compile. More on principal component analysis is we're going to get each data point's few first important components, and this is going to create a lower dimensional representation of the data. We're now not going to have this heavy in terms of memory and data points and features image. We're going to have a lower dimensional representation of it. This is going to still preserve as much of the data's variation as possible, meaning when we pull out the most important components, most important features of an image, we're not going to pull so few features that the image is now unable to label. We're still going to keep the key features that are going to allow us to label the image. For example, to label that image as a number 1, that image as a number 2, that image as a number 3. You have to make sure that when you're pulling out the principal components, you're still preserving the data's variation. You're still preserving the image's uniqueness. Now, the second part of unsupervised learning is known as cluster analysis. This is related to principal component analysis, but it's slightly different. Here on the screen you can see a visualization of cluster analysis. This time we have the data points plotted, but they're also in different colors and circled. That's because cluster analysis can group your data points into separate clusters, and that's how it helps with classification. For example, you would group all the number 1s in one group based on the graph, and perhaps the white circles are a number 2 image, so they're all grouped, and the images showing number 3 are all grouped as well on your graph. That is cluster analysis. Let's break it down a bit more. Cluster analysis finds commonalities in data. It's going to graph the data in such a way that you can see the different groups. You can have, for example, a whole bunch of images of animals, and you can graph them in such a way that the cats will be grouped to one side, the dogs will be grouped to another side, for example. And that's because you will plot them based on the relevant features. Cluster analysis reacts based on the presence or absence of commonalities in every new input. This means that when I'm getting a new image, I'm going to classify it based on whether or not it has a commonality with a certain group. Let's say I'm training my model to recognize cats and dogs. When I get a new image, it's going to compare its features to see if it has commonalities with what I've already learned about cats and dogs. Now, of course, because we're using unlabeled training with unsupervised learning, the model itself won't know this is a cat, this is a dog. It'll just know that there are 2 separate groups, because the features, it has found patterns in features that can separate images into 2 different groups. Cluster analysis helps us detect data points that don't fit into any group as well. And that is unsupervised learning. In this lecture, you learned the applications of unsupervised learning. You learned that it has applications across many different industries like medical and business fields. You then learned about supervised learning and compared it with unsupervised learning. You learned about the two main components that make up unsupervised learning. Those are principal component analysis and cluster analysis. Now that you have an overview of this type of machine learning, we are actually going to build out unsupervised neural networks coming up in this course. We're going to build several projects together, and they're very exciting. They are going to utilize the power of computer vision in order to recognize images. I'm very excited to take you into our projects, so let's go ahead and get started in the next lecture. Hello everyone, and welcome back to Mammoth Interactive's Complete Machine Learning course 2.0. In this lecture, I'm going to show you how you can build machine learning models and run them, train them, test them, visualize them, all on the web. That's right, you don't have to download or install any software for this course. Now you can if you'd like to. If you prefer to run your Python scripts via PyCharm, Visual Studio, Atom, you can run them using an integrated development environment, a program like that. For that, you'd have to download and install that software. But there is a way to build models that are functional, working, and ready to use right on the web without any installation or downloading. For that, just visit the website collab.research.google.com. This is going to take you to a website known as Google Collab, short for Google Collaboratory. You can log in with your Gmail account and you'll be taken to Google Collab. It's kind of like Google Docs for coding. Any code that you write in Google Collab, you can execute right here in Google Collab. The default is Python, but you can extend it to other languages. For example, if I type print hello, this is a Python print statement printing out the string hello. All I have to do is run the code cell by clicking this run button, and it's going to execute any code in the cell. The first time it runs, it has to connect, so it's going to take a bit of time, a few seconds, but for any subsequent cells, it'll run faster. And look at that, I got the string hello being printed. This means that my Python code was executed as a Python script. Typically, you would do this in a piece of software like PyCharm, but Google Colab makes it very easy to run Python scripts. Here in Google Colab, you can also just add text if you want to add hints, and you can format the text as well. If you'd like to, you can go to File and you can upload a notebook. With this course, we're going to provide all the source code for each lecture. You can find it at the end of every section. You can upload your own notebooks. They just have to be a .ipynb, which means a Jupyter notebook type. And if you upload a notebook here, you can run its code cells. You can save a copy of the notebook to your Google Drive, or download the Jupyter notebook file, or the Python file if you want to save it as a Python script. A Jupyter notebook file is a Python file that you can run on Google Colab or on Jupyter Notebook. Some more things you can do with Google Colab here is you can edit cells with this Edit tab, you can view a table of contents and more. You can insert code cells, text cells, section header cells, and more. You can run all of the code cells at once with this Run All button. That is a useful button because if you close the notebook and you reopen it again, you'll have to run all the code cells again. Because with Google Colab, if I make a cell like I declare a variable called dog and I set it to equal Scruffy, if I don't run this code cell and then I start a new code cell and I try to print dog, I'm going to get an error saying that the dog variable was never declared. So you want to make sure you run every code cell if it's important to the current one. There we go. More you can do is you can interrupt execution, You can restart the runtime. You can add an accelerator, a GPU, to make your code run faster. You can also manage all of your sessions to delete them if you want to stop a session from being run. And you can access some settings if you want to set preferences. Google Colab is quite a useful tool. You can share your Colab files with anyone you're working with. So this is what we are going to use to build our machine learning models together. We're using Google Colab, so that way you don't have to have any system requirements. This course will be compatible on Mac, Windows, Linux. Let's go ahead and jump into our first project. Now that we know how we're going to build out our Python files and our algorithms, let's jump into our first project. I'll see you in the next lecture.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy it before the sale ends. Thanks for watching, and I'll see you in another video.